Hello and welcome to More Math Homework Help. I am Miss Moore and I am back for another Wednesday night homework help. If this is your first time, welcome. The way it works is that you call in or you type in a homework question. You can put your question in. What helps me the most is if you submit your questions through the Google form in the description of this video. So if you look right now in the description video, it should say submit questions here. That is the form that you submit questions on, and I will take your questions. There are specific subjects that we do go over, so nothing above algebra. But yeah, I am here to help. So we do have a student guest. I'm so excited, and we're going to be talking about percents today. All right, so I'm going to bring on our student guest. Hello.
Hello.
Welcome. So I'm so happy to have you here. So you told me that you wanted help with percents, right?
Yes.
And finding the part, the whole, and the percent. So that is what we're going to work on. So let me share my screen. Okay. So, and I am doing some troubleshooting because right before we got on, my whiteboard decided to stop working. So hopefully all will go well as we're doing this. But tell me what you do know about a percent. So if I tell you like 40%, right? What does that mean?
It's out of 100. So
Good.
40% would be like 40 out of 100 if you put it in fraction form.
Good. Perfect. So you already know what a percent is, which is half the battle, right? So a percent is just a number out of 100%. You knew that. 40% is 40 out of 100. Okay. So if they want you to find 40% of, let's say, 50, okay? So 40% of 50. Is that all of 50?
No.
Okay.
All of 50 would be 100%.
Good. So how much is like 40%?
Close to half of it, but
good. Okay. Because half of it is what percent?
50%.
Good. So when we do problems like these, like 40% of 50, I love that you said it's close to a half, because what's half of 50?
25.
25. So I'm going to look for an answer that's like close to 25, right? Because 40% is close to 50%. 50% of 50 is 25. So I want some kind of number that's close to 50. Okay. So how would you normally solve this? Or is this where you get stuck?
This is kind of where I get stuck. So it would be, I would do like proportions. Wait,
okay.
Not proportions, like kind of like fractions. So I would do like 40 over 50. Which equals x over, 40 over 100 equals x over 50.
Excellent. And 50 represents what?
The whole.
Good. 50 represents the whole amount. I'm taking a percent or a part of 50, and I get this new amount, right? The part. Right. So good. 50 represents the whole. Good. So you have half the battle right here. You already know about percent proportions, because I was going to ask you which one you preferred, because there's equations and proportions. I'm going to show you equations if you haven't seen it yet, because that might help you understand this better. Okay. But let me just see what you do with the proportions. So keep going.
I would cross multiply 100 times x, which would be 100x.
Awesome.
And then 40 times 50, which would be 120.
Okay, 40 times 4 times 5.
4 times 5. Oh, 20, 200.
There you go. Okay, and then add your 2 zeros. Okay, so now, 100 times something equals 2,000. What would you do next?
And then I would divide it because you want to isolate the variable.
Good.
So I would divide both sides by 100.
Excellent. Okay, and then x equals
20.
Yes. Okay. So now we got x equals 20. Perfect. So that is what we call what? So we have the whole, we have the percent. Now we just found what?
The part.
The part. Good. Awesome. Okay. So now.
Well, what I struggle most with is finding the percent. I know how to finding the percent and finding the whole. Finding the part is kind of easy, honestly. It's not
okay. Thank you. I love when you let me know specifically what it is. Okay. So 15 is what percent of 35? 15 is what percent of 35? So let's do it. Okay. How would you set up your proportion?
So we know the percent. No, sorry. We know the part and we need the whole.
Okay. What is the part?
The part is 15 and the whole is 35.
Good. Okay. And then the whole is 35, you said. Okay. What am I putting on the right side?
X over 100.
Excellent. Because it said what percent. So we have x over 100. Now what?
Cross multiply?
Mm-hmm.
Okay. Which would be 1,500 and x multiplied by 35 equals 35x.
Good. Okay. I'm going to write it on it doesn't matter what side you write it on, but just so that's easier to see. Now, what do we do?
We divide both sides by 35 because we have to isolate the variable.
Good. Okay, so let's do it.
35 times.
That was a horrible division sign just now. Oops. Okay, put the numerator in the house, make it look like money. And tell me what we're getting.
12. 35 times 3, 15, 3 times 3 is 9, 10, 35 times 4, 20, 4, 8, 12, 14. So
I just realized I didn't make this a very pretty number. So maybe, all right, let's go a little bit easier on you because I just realized this number is going to come out crazy looking and take forever to divide. So hold on. I just made this one up off the top of my head. So hold on. Let's change it to 40. That way it's a prettier number to work with. Yeah. Okay. So now we have 40x. 40. Now this should be a little bit easier to divide. Okay.
1,500 divided by 40. And then 40 times 4, because that would be 100. No, that would be 160. 40 times 3.
Good.
you would get 30 at, bring down the 0, 300. 40 times 8. That would be 32. So 40 times 7.
Good.
8. 28. And then we have 28. We get 20 decimal 0, 0. 40 times 5. And then, okay, 37.5.
Excellent. All right. 37.5 what?
Percent.
Excellent. Good. Okay. You got it. So that was percent. How do you feel about that?
Pretty okay.
You seem to know exactly where to set it up and exactly what was the part and what was the whole, which is 75% of the battle. And you also know how to cross multiply and do the hard part. So you do know how to find the percent. I'm gonna give you some more of those, but let me try you with finding the part. Okay. I mean, was it finding the part you needed? No, find the whole. Find the whole. Okay.
It's just I can't remember like how to set up each problem, if you know what I mean. Because like you forget sometimes that you're like finding the percent instead of finding the whole, and then you like have to go through the whole problem again. So
I gotcha. So I'm wondering if it's an actual word problem that you need, because I feel like when it's in this state, you actually get it. So when it says like 42 is 24% of what number, you know exactly where to set it up. I'm wondering if it's like a word problem where it's not so clear, like it's not this wording.
right. Yeah.
Okay. That's what it is. Okay. So do this one for me right now, and then I'm going to get a word problem ready for you.
42. Got my answer.
Okay, what did you get?
170.
Okay, let me check that. 24%. 100, say it again.
170.
Almost. I'm getting 175, but it could just be.
Oh, sorry. Yeah, 175. I read it.
Okay.
Right.
Good. All right. Excellent. So now let me lock this on the page. Oh, they don't let me lock it. Okay. Let me delete this. Okay, here we go. So, can you see that? Let me enlarge it.
Yeah.
Okay. So, Danny just hired a new employee to work in his bake shop. In 1 hour, the employee burned 625 chocolate chip cookies. If this represents 25% of the day's production, how many cookies were produced that day? So, first things first, tell me what's some important information here.
The employee burned 625 chocolate chip cookies in an hour.
Mm-hmm.
And that represents 25% of the whole production.
Mm-hmm. Okay. Are you listening? Are you watching this? Like, do you have the YouTube up?
Yeah.
Okay, because it's giving some feedback.
Oh,
So if
I'm
you
sorry.
could, oh no, it's fine. I was like, how come I can hear myself? Okay, so it says how many cookies were produced. So tell me this: how would you set up this proportion?
25 over 100, because that's the percent.
Good.
And it's 25% of the day's production. So we're finding the whole. So 625 over X.
Excellent.
Okay, good.
And that was good that you realized that we were finding the whole, right? Mm-hmm. So you really, I could tell as soon as you said this represents, so you said 625 cookies were burned. That represented 25% of the whole production. You actually used that language saying it represents 25% of the whole. You knew that 625 wasn't the whole, which was great. Okay. So now tell me what to do.
Cross multiply.
Mm-hmm. Why you say like you're not sure? You got this. So what are you gonna put?
Got 25x, which equals 62,500.
Awesome. Good.
Divide both sides by 25.
Excellent.
50, 12 under 25, which is 5. And then 2,500 is the whole.
Good. Okay. Divided by 2,000. And that's excellent. You got it. So let me do it again. This time with a different one. Okay, let's see.
Could you give me like the percent that's like not like one of like the checkpoints, like 25, 50, or 75%? Like let's say like a 33% or like a 46%.
I gotcha. Okay, let me see. Okay, let's do this one. So I'm gonna read it as I type it. Mm-hmm. That way it goes faster. Okay, so Sally's soccer team played 25 games and won 17 of them. What percent of the games played did the team let's make it interesting. Okay. All right. So what percent of the games played did the team lose?
So they played 25 games and won 17 of them.
Mm-hmm.
Total played. And that equals X over 100 because I want to find the percent
Good.
And then subtracted from 100 to find the percent that they lost.
Nice.
25x.
And you know what? You also, just to give you another shortcut, because if they won 100% of the games, how many would that be?
25.
Right. So if they won 17 out of 25, how much did they lose?
They lost 8.
Yeah. So you can actually do 8 out of 25 from the start.
Oh.
Subtract. It's fine. Both ways will work. I just wanted to give you like a little bit, show you a different way to do it. But both ways will work. So which way do you want to do? It doesn't matter. Uh-oh. I think I lost you. Wait, what did you say?
Can you hear me now?
Yeah, there you are.
Okay. I'm going to do my way, and then I'm going to do also your ways to see how different they are.
Okay. Sounds good.
They lost 68% of the games. No, they won 68% of the games.
There you go.
Lost 32% of the games.
Nice. Good catch. Okay. Now I want to show you a shortcut. I know I wasn't supposed to give you pretty numbers, but it just worked out. So it was 68%. I mean 32 and 68%. So those weren't pretty. However, watch this. When you have, remember, proportion is 2 equal fractions.
Okay, yeah. Mm-hmm.
So if you can find a relationship between like the denominators or the numerators, you don't even have to cross multiply. So 25 times what equals 100?
4.
Okay. So then all you had to do was 17 times 4 to find out what x is.
Wow.
You see it? So that's just giving you some shortcuts to do because it will help you. So if it was like any multiples of 10 is going to help you with the denominator, right? If it's something over 10 equals something over 100, you would just do times 10 to figure out what that something is.
Right.
You see? So that's just a little shortcut to help you out. Okay, let's try another one. But it seems like you're getting the hang of it, which is great. Like I said, that's half the battle right there. Okay, so okay, let's do some like real world problems with percents, like discount and markup. Okay, use a 30% off coupon to purchase a sweater. If she paid $33.60, what was the original price of the sweater? There we go. So how you feeling so far?
Okay.
What would make you feel better?
I don't know what would.
I think you got this. You're just not confident that you got it.
True.
I'm telling you, I have students that come on here that don't even know how to set up a proportion whatsoever. The fact that you knew how to set up a proportion, you knew the terms, you could identify the whole, the part, the percent. You are like light years ahead. So I want you to be confident that you know this stuff, okay? I'm gonna keep helping you till you get confident, but I just want you to know you got this.
30% off. She paid $33. What was the original price of the sweater? So it's already 30% off of the original
Mhm.
price. So we want to find the original price. We will be adding the 30% back to the
Mhm.
what do you call that price? To the discounted price. So
Good.
KU
Just got that sounds,
purchase if she paid $33.50 over the original price. So 30 over 100 equals, that is, we want to find the whole. So
Mhm.
over x and then cross multiply, which would be 30x equals 3,360, right?
Yes.
Okay. 30,360 by 30, 30, 36, 30, 60. 112 was the original price. $112, I think.
So almost.
Oh.
Okay, so let me tell you this one. No, this was a very challenging problem. Okay,
Right.
because they didn't just say they didn't give you the original price and ask you what the amount of what the new price is, right?
Mm-hmm.
They also didn't tell you how much that 30% was. We just know it was 30% off.
Right.
So I want you to read it again, right? If I use a 30% coupon to purchase a sweater, am I paying full price?
Are you paying full price?
If I use a 30% off coupon.
No.
Okay, what percent am I paying?
70%.
70%. So this $33.60 that she paid for the sweater was 70% of the original price. You see it?
Yeah.
Okay, so that was 70% of the original price. And then, and then go from there. Okay,
Okay.
so try it and tell me what you get.
$48.
Good. Okay, so I want you to look at this, right? Because originally you had 112, right?
Mm-hmm.
So what's 50%? What's half of 112?
Half of 112.
So 11, 2 goes into 11 how many times?
2 goes into 11. How many times? 5 times. Oh.
Good.
So
And then
51.
2 goes into 12.
2 goes into 6 times.
Good. Okay, so it's 56. So if I had a 50% off coupon, I would be paying $56. Now, is a 50% off coupon, am I going to get more of a discount or less of a discount with 30%
I
off?
can't hear you.
Oh, no. Can you hear me now? Oh, no. What happened? Are you able to hear me? Oh, no.
Yeah, I can't hear you. Let me see real quick. It might be my end.
Okay, you might have to go out and come back in. Let me see. My mic is on.
It's my stream.
Okay.
Okay.
Let me see if you can. I'm going to type it here. Okay. She saw it. Good. All right. So this is a good time to let you guys know if you are if you're watching and enjoying and you have a question tonight or any Wednesday, don't forget you can submit questions through the Google form in the video description. Okay, so if you have any homework questions whatsoever, go ahead and submit it through the Google form. All right, can you hear me?
Yes.
Yay, we're back. Okay, so if you had a 50%, so let's say we went with your original answer, right? 112. And this is a very common mistake, so don't even worry about that. But let's say it was $112, right?
Mm-hmm.
If I have a 30% coupon, am I going to get more of a discount with that or 50%?
You're going to get more of a discount with the 50%.
With 50%, right? So if at 50%, I'm only paying $56, right? And that means it should be less than 30%. So if I get down to here, that wouldn't make sense because that would mean I would have a huge discount, right?
Right.
And that couldn't work. However, if we're looking at the $48, 30% off is still pretty close to it should still be pretty close to that original price. Okay. Mm-hmm. So $33 and $48, it makes more sense, right?
Right. Yeah.
Because 10% of 48 is just $4. So if it's 30%, you're looking for about like $36. Okay. Mm-hmm.
So you need like common sense and you use math.
Yes. That's really what it is for these percent questions, especially when it comes to like discount and markup. A lot of times it's really like, okay, think about it how we would do it like if we're paying for some clothes. Like a lot of times that's how it kind of works out. Okay. Right. Try this one. Wow, there's a lot of like 25. Okay, let's try number 2. All right. Person eat 2,400 calories in a day. Of these, 36% came from fat. How many calories came from fat? Okay. Okay, I want you to set up the proportion. Tell me exactly how I should do it.
Okay, so person ate 2,400 calories in a day. Of these, 36% came from fat. How many calories came from fat? So we're finding the part because the whole is 2,400. And we want to know what the percent represents.
Nice. And I spelled calories wrong.
And then so you multiply. Wait, okay, got it. Never mind.
Nice.
And then 2,400 multiplied by 36. 6, 12, 18, 24, 6, 12, 14, 0, 0, 4, 8, 12, 1, 3 times 2, 6, 7. Add these together, you get 0, 0, 4. Is that a 4? That's a 4. 6, 8. Okay, so we have 8, 6, 4, 0, 0.
Nice.
86,400?
Good. Okay. And what's next?
So 100x equals 86,400. So you divide both sides by 100.
Nice.
100. So you have 8 right here.
Mm-hmm.
6 right there. And we have 4 right there. 864.
Very nice. Excellent, right? And it makes sense, right? What's half the calories? What would that be?
Half the calories would be half of a 86,400.
No, half of the whole amount.
Oh,
What was the whole amount?
whole amount was 2,400. So
So if
half of
50% came from fat, how much would that be?
1,200.
1,200, right? So 1,200 came from fat. So if it's only 36, it should be somewhat near 1,200. So I always like to use that as my baseline. Like if it's
Right.
somewhere close to 50%, then you know, okay, it should be under 1,200, but it shouldn't be crazy too far away.
Right.
Okay, nice. Good job. All right, let's do one more because you got this. Okay. Oops. All right. Last one. Okay.
And after
Mm-hmm.
this, can I ask you another question for another
Oh, yeah.
Okay.
Wait, when you say, oh, you mean math subject?
Right, yeah, math, not like reading.
I was like, girl, I'm just a math teacher. Don't give me those social studies. I might be able to do reading, but you ask me a social study question, I'll be like, we both failing. Okay, so this one says the hockey team won 63 out of 84 games it played this year. What percent of the games did the team win?
Okay, so we have 63, 84. So they won, so we can use that. We don't need to do no simplifying or anything.
That's true.
And then we're finding the percent.
Good. So tell me what you're doing for your proportion.
63 over 84, that equals x over 100.
Okay.
And then multiply. Thank you. I got 6,384x.
Good. So we cross multiplied.
Divide both sides by 84.
Nice. Isolate that variable and go ahead and
4 times 5. 40, 420, 84 times 7. $518. Subtract that. And 2, 1, 1. And then we have 84 times 10. Wait, let me see. 8. That would be, okay, so not 10, but 84 times 12. 16. 4, 8. 8, 10. If I add another 84, that would be 1,090. Okay, so 84 times 14. 16, 8, 16, 24, 32, 33.
What numbers do you have so far?
7.
Okay, good. You're almost there. That's only one more number left.
2, 11, 1,076. So 84 times 13. Wait a minute. Okay. Wow.
Did you get, when you subtracted, did you get 420?
No, I got 1,120.
1,000. Okay, did you borrow? That might be where it was.
Yeah. Okay, let me do it again. 6,300 divided by 84. And then we had 518. Subtract that. So
Oh, that's what it is. You're 518. 84 times 7. Do that.
84. I got 518 for 84 times 7 though.
Okay, so do it again. Do 84 times 7. So 4 times 7.
8 times 6 is 48. 56. 58. 588. Okay, there
you go.
588. But 12, 10, 2, and then we got 6, 4, 42, 420. That was easy. Okay. 75. Right?
Nice.
Okay.
Okay. 75 what?
Percent.
Excellent. All right. So tell me, so how are you feeling about this?
Pretty better than before.
Yeah, you are, right? So, I mean, the only error I see is just like small stuff that has nothing to do with percent. So you're good. So, but overall, you absolutely understand, even when it's just not like, what is 5% of 4, right?
Mm-hmm.
You understand like the harder concepts of percent, discount, any real world problems of percent. You get it. You know how to set up the proportion and you are good to go. So, all right, tell me your next topic.
What is it called? It's like many numbers, and then there's PEMDAS. Something to do with PEMDAS.
Yes. Order of operations.
Yeah. Like okay. How to do with like many numbers, negative numbers, like everything mixed together in one equation. Oh my god.
Okay, so in 6th grade, you actually did like negative numbers.
Yeah, you learn
like adding and subtracting integers
and multiplying and dividing, because that's easy. Honestly, multiplying and dividing is just easy.
Okay. Yeah. So I know what you mean. So you mean like if you have a problem like plus.
Oh, there you go. Exponents. Oh my god.
Okay. No, that's not right. Let me do. I'm gonna put a 12 minus 4, and then I'm going to make this a 4. Okay, so you can see that, right? So tell me, what do we do first?
You write PEMDAS down because like you need that. That's what I would do.
Okay. Now, what's special about PEMDAS? So I'm going to, I don't know if your teacher wrote it this way, but this is how I like to write it for my students.
I write it, I like circle M and D when I write it vertically.
Okay.
And then I circle them and put or on them, the word or.
Nice.
And then I at the bottom I put left to right.
Okay. You do like you write the word left to right, or you like
L to R.
Oh, okay.
Yeah.
Interesting. Okay, so hold on. Let me see if I can get how you write it. Let's see. So you write it normally like this, right?
Mm-hmm.
And then tell me what you do with the M and the. You put a circle around it.
I lost you again. My internet's so bad. I'll be right back.
Okay.
Oh my god.
Technical difficulty. Foul on the play. Well, for those who are watching, hello, welcome, welcome, welcome. If you have any questions at all as you're watching, go ahead and submit your questions on the form in the description of this video. Any homework questions you have, go ahead and submit. All right. Are we back? Are we good?
My Wi-Fi is not the best in the world. I'm sorry.
It's okay. You're fine. We got you. Easy fix. Okay. So tell me, you said you circle it. Do you circle it like this?
Yes, and then I write or in the middle, but you don't have to. Like, I get it.
Like or right here?
Mm-hmm.
Okay. And then what?
And then circle A and S and write or, and then L to R.
Where do you write the L to R?
At the bottom.
Okay. Like that.
Yeah.
Okay. That works. Okay. So yeah, that's basically, I just teach my students to put it right next to each other here, just so that you know one is not better than the other.
Right. No,
So
that makes sense too.
both of them work. Whichever works for you. Okay. So as long as you know that parentheses come first, you are good. So actually, let me write that again because you guys need. So do that. Okay. Oh, where'd it go? Okay. And my computer's acting up right now. Let me just type it, let me write it because they don't want me to. Okay, so keep going. Where do I start?
You start with the parentheses.
Okay.
So 12, let me write on my paper too real quick. 14 plus 12 minus 4 exponent divided by 4. And then 12 minus 4 is 8.
Good.
And then you bring it down so like you can like see it more clear.
And actually, let me erase this. Okay.
So if it's 8 to the second power, it'd be 8 times 8, right?
Mm-hmm. Good.
So we have 14 plus 64 minus 4.
Nice.
And now left to right, because there's like the same thing. So not the same thing, but like they're equal. 14 and then 78 minus 4, 74.
Oh, wait, it's division.
Oh, oops. Couldn't see the dots there. So 78 divided by 4.
Mm-hmm.
38. And then 4 times 10. 4 times 9. 36.005. 19.5.
Okay, so you got, hold on one second. Let me just double check this. So you did parentheses first, you did exponent, and then you went down to addition. You see it?
I see what I did wrong. I didn't do division first.
Okay, so yeah. So there were so many operations in here that you literally, like, you see how I check it off?
Right.
You literally have to do that because it can get like really crazy, especially when I throw negative and positives in here. It can get insane. So go ahead and divide first and then tell me what you get.
Okay. $16.
Good.
And then 16 plus 14, which is 30.
Nice. Okay. So that's the biggest thing. With order of operation, there's like so many, what makes it complicated is you have a bunch of operations happening at one time. That's really what makes it like really hard. Okay, let's do it again. This one, I'm just going to do whole numbers, and then the next one, I'm going to add in integers. Okay.
Okay.
Okay. Where do we start?
We have, is that a 13, right?
Mm-hmm.
Okay. 13 to the second power minus 5 multiplied by 6 plus 6 divided by 3 to the second power. Okay.
Mm-hmm.
Now we would do the parentheses, which is 6 divided by 3, which is 2
Mm-hmm.
to the second power. Okay, here's where it kind of get confusing because I did parentheses, right? So would I
Right.
do the exponents on the left or do the exponents on the right first?
It doesn't matter.
Really? Okay.
Yeah, it doesn't.
2 times 2 is 4. 13 times 13. And 9, 3, 0, 3, 1, 9, 6, 1, 169. Ooh.
Mm-hmm. Okay. Exponents
9
taken care of. Now what?
times 6 plus. Okay, so we did parentheses, exponents, multiplication. 5 times 6, 30. 169 minus 30 plus 4. And then we have 169 minus 30, which is 139 plus 4, which is 143.
Nice. Good job. Look at you.
Thank you.
Nice job. Okay. So that was a lot easier, right? Taking it one at a time. So yeah, when it comes to like exponents, I mean, both of them have to get multiplied with each
Right.
other. So it really doesn't matter. As long as you're not doing any other operations, you're good.
Okay.
Like once you handle all the parentheses and you're just down to like exponents and other operations, do whichever one comes first. It doesn't matter.
So why do we change from like the multiplication symbol to like a little dot?
Oh, great question. Okay, so this year you did things like, tell me how you would simplify this expression.
Ooh, I would add 5x and 3x.
Okay.
I think. I'm not sure. I haven't done this much.
That's fine. But right, so you would just like, so it wouldn't be adding, it would be 3x minus 5x, but you're right in terms of these are the like terms, right? And you'll put them together. Now watch this. If you were to write 3 times x plus 4y minus 5 times x, that looks confusing, right?
It does.
Right? So the reason why we switched from using x is because now you're getting into algebra. When you hit 6th grade, they're like, nope, we don't want to use any more x's. There's a time in the year where they switch over because you're using x as a variable. So that's why they make the switch, because they're like, this is confusing. Is it 2 x's? Is it multiplication? So that's why. Okay. So let's do some integer operations. Okay, let me do a better number. -16. That should be good.
2 to the third power minus 4 times 1 plus 5. First, you do the parentheses.
Good.
Which is -1 plus 5, which is 4.
Nice. Okay. Parentheses taken care of. Awesome.
And then we have exponents. 2 times 2 times 2, which is 8.
You are on fire.
Thank you.
Okay.
So now we have 8. And then -16 divided by 8 minus 4 times 4. Right? Now you do left to right, because -16 divided by 8. -2 minus 4 times 4.
Oops.
And then 4 times 4 is 16. Negative 2 minus 16. Negative 18.
Nice.
Okay.
Why did you say it like you're unsure?
Because since it's a negative minus a 16, I get confused if you would just like take it off of the 16, so it would be a 14, or would you add it, which would be an 18?
Gotcha. Okay. So did your teacher teach you keep, change?
Yeah, keep, change. Oh no, but I thought you were gonna say change, flip. Anyway, no.
They didn't teach you any of that. Okay, so one way to think about it is you start at negative, and anytime you're subtracting something, think about a number line. Like if I'm at -2, which way am I going if I'm subtracting?
You're going left because you're subtracting.
Right. So if I'm going to the left 16 spaces, right, am I going to end up higher? You would basically have to go 16 spaces. You can count it on a number line if you want to, but just know it's going to be like,
right.
It's almost like you're adding it to the negative.
But my teacher did teach me like, if it's subtraction, like make it adding and then change the sign to a negative.
Okay, that's what keep, change is. So they may have said it. They may have called it something different, but keep, change is keep the first number the same, right? So we keep -2 the same, change subtraction to addition, and then change 16 to its opposite.
Right. Okay, that makes more sense. Okay.
Yeah, and then it's the same sign, adding keep.
KCC.
Yep, keep, change. And then it's like easy to remember. Right there. Okay. But you had it. I mean, you knew exactly what operations to use. And then you also knew, this is a lot. Look at this screen. This is a whole lot. So you knew exactly what operations to use. You didn't try to, I was worried at this point. I wasn't sure if you were going to get it. Oops, hold on. If you were going to get this. So I was waiting to see if you would subtract first or multiply, but I could hear as you were going, you kept saying, okay, that's multiplication. So I knew you would most likely get it. And then you did great with this 4 times 4 and kept that minus there. You did awesome. So you know your order of operation. It's just a matter of, which is the hardest part, integer operations. So, so with integer operations, now that you're out of school, I would say like memorize that. If there's a, I need to find an app, but like if there's a phone app that has like integers, you know how they have like multiplication flashcards?
Right.
It's almost like that, because in 7th grade, you're doing nothing but integers, and you're also going to have to do things like -2/5 x plus 3 equals -4 6, right? So you would not just have the negative and positive, but you would be adding it to fractions and doing a lot harder concepts with it. So have you done that yet?
We did a little bit like right before school ended, and I got like a bad grade. Okay.
But the majority of it is just making sure you know your integer rules backwards and forwards. So by itself, each integer rule is like, oh, I got this. I got adding integers. And then you learn subtraction. You're like, oh, keep, change, we got this. And then you do, multiplication, division. And by itself, it seems so easy. And then when your teacher's like, all right, so now combine them all, you're like, wait a minute, do I keep the sign the same for adding? Wait a minute, which one is that? Right? It's so easy to confuse it. So I would say to like over the summer, know those integer rules backwards and forwards, because that's going to be like 50% of the stuff you do in 7th grade. And then if you could do, how are you with fractions?
Pretty good.
Okay, so if I say, what would you do?
I will multiply 1/5 by 7 over 7 and 4/7 by 5 over 5.
Okay, good. And then add them together, right?
Right.
What if this was subtraction? Let's make it a little prettier. Okay. So if it was subtraction,
I would like, how do I say this? Like, you know how you like subtract normal numbers, like put in like that formation, but like you can borrow and then numbers, and then like 1/5 would turn into 6/5 and subtract that.
Nice. Okay, good. Okay, so you know how to regroup with fractions. You know how to add, which is great. Now, what about multiplication?
Yeah, that's easy because you
Okay.
just multiply. There's like no rules, just multiply.
Yeah.
Numerator by numerator.
Now division.
Division, case, keep, change, flip.
Nice. Okay, and that 4/5 will become 4/7. Good. Okay, good. So you know your fraction rules, which is great. So yeah, once you get your integer rules and you're like, boom, got this, 7th grade math is going to seem like a piece of cake. Okay, but I'm going to be here this summer. I'm figuring out the summer schedule, but definitely July. I think we're going to do 2 more of this homework help because in the Northeast, our students are still in school until June 18th, I want to say. Some schools go until the end of June. So I'm going to do about a couple of more weeks of these homework helps. And then I'm going to start like this summer help, which you're kind of getting now, but we'll do some summer sessions. All right.
All right.
Well, thank you so much for joining us. You did absolutely wonderful. Stay here while I close out the show. Okay.
All right.
Okay, so that was amazing. She did an amazing job. This tonight we did percents with percent proportions, find the part, find the whole, find the percent, and then we ended with order of operations, which was phenomenal. So round of applause to my student guest. She did great. And the more she did, the more confident she got, which was awesome. Amazing. And that is the More Math way. So I will see you guys next week at 8 p.m. Eastern Standard Time right here. And if you ever have any math homework questions that you need help with, go ahead and submit the form in the description of this video. Have a great night, guys. Bye.